All right, like I said, I'll start right on time. So if you're here, that's a good thing. All right, let's go over the homework. I'm gonna go over it slow. So if you've got any questions as I go through it, ask, okay? So we'll try to clear anything up. Number 2 wanted you to find what side A, B, and H of the triangle given. And we are given some information. So everyone can see that, okay? Yeah, perfect. And uploaded the file. Yeah, I'll look in a bit. I'm just gonna make sure I label it correctly here. A is the upper right, C is the bottom, B is the left. That's correct. All right, so this is 25. They give you a hint on the H to break it into right triangles. That's probably the easiest way to go about a non-right triangle. And they gave you angle A as 48 degrees. So what do we do? What do we do? Anyone have any ideas? How'd you solve it? So working with this triangle. Yeah. If you go sine 48, we have to know what? We have to know sine 48 degrees equals, that would be H over B. Do we have any of those? We just have C is 25 feet. Right? And we have A is 48 degrees. So we have that, but we don't have this, we don't have this. Correct? Yeah. Now what? I like it. You just got to write it out and be honest with the variables, like, oh, I don't have those two. We could. Yeah, so they kind of threw a non-right at you right away. So that's a problem. So if you only know this and this, no matter what triangle, right triangle you build, you're in trouble. So this ended up to be a non-right triangle. We have to kind of work it as a non-right triangle first. Now, can we use the law of sines? It's a good question. We have to remember the law of sines, right? And unfortunately, I didn't cover law of sines or cosine law on the first day, so didn't really help you with this one. I didn't expect them to throw a non-right, or at least I expected them to give you more information than that. So I'll do better at looking at the homework problems to make sure that we've got things covered. But let's do this, because this is what we're doing today, is non-right triangles after we get through the homework. So non-right triangles, we use law of sines. And that is, anyone remember it? Well, you could look it up. Yeah, so, whoops, I already messed it up. A over the sine of A, but it's the side A over the sine of the angle A. And then that just repeats. B over the sine of B and C over the sine of C, where these are caps because they're angles and these are lowercase because they're sides. And with the sine law, we can use any two. I can use those two. I could use these two, or I could use those two. We don't use all three. That's too many unknowns, right? So any combination. We know an angle, 48. We know a side, C. The problem is we don't know the side opposite, right? So we could use like this one and this one. The problem is we know that, but we don't know that. We know that, but we don't know that. We'll end up with two variables, right? So let me write that. And honestly, in the beginning, this is how you're gonna try to solve these things. You're just gonna try things. And once you write the equation, if it doesn't work, if you have two variables, then you can't use it, right? There are little rules that we'll kind of cover, like when you know an angle and a side, that is going to be the cosine law, not the sine law. But let's prove that. So I'm going to use the angle A. So I got to use this one, and it's going to set up A sine 48 equals, and I'm going to use this one because I know C. 25 sine of C, because I don't know C. They would have gave us just one more. They did? Oh, good catch, Ray. That changes the whole game. Right there, 90. Dude, it's a right triangle. I didn't even notice that. So bad. All right, the hell with that, right? We don't need that. We have a right triangle, it's just on its side. Like that. So you said use the sine law. Yeah, perfect. Nice. That's funny. So sine of 48 equals opposite A over hypotenuse 25. A equals, how do we solve that? Yeah, the question too, how do we solve that is always isolate the variable, right? So then what do? You got to multiply both sides by 25. Again, you don't have to show me this move. I'm just doing it so you see what I'm doing. Right? So that eliminates everything. A equals that. $48. 185786. Yeah. So what's this round to? Yep. And what's the unit? Feet. Wow, that was a long route to a simple problem. Phew. Read the problem, I guess. Right triangle. All right, what else did we want? We wanted B. That's this. What should we use? Sine, cosine, tangent. Which one? We just use sine to get A. Cosine, yeah. So my own philosophy is I try not to use what I just calculated because I could have screwed that up. So I want to use B, which is the unknown, and then 25 again. So cosine 48 adjacent side, that's adjacent to the 48 over the hypotenuse. Again, same kind of manipulation. I'm not going to show it. 48 cosine 25 times. Correct. 16,728. So what? 16.73. And units are feet. And then the last one is H. So that's this one, right? And that does create a right triangle right there. And now we know B, and we know 48. We could get H. We don't know this X dimension, right? So what should we use? New triangle, because they want H using that triangle. Sine, cosine, tangent. If we know 48 and we want to know H, that is opposite of the angle, right? So we should use sine. We know B now, don't we? We just solved for it. Kind of got to use our number that we calculated. So sine 48 equals opposite H over B 16.7. And I'd want to use this number. If you're good at storing, that's the way to go about it. Store it in your calculator. If you're not good at storing, go 4 places. So 7283. That'll keep your accuracy good. Okay. So don't use the 1673. That's rounded. That'll make a pretty inaccurate number for H. So then H equals that times 48 sine 12,431. Yeah, that was a lot easier once we realized it was right triangle. Once I realized it was a right triangle. Questions? So if you got your homework in front of you, I encourage you to write on it, like write on it. Use a different color or whatever device that helps me, but put notes on it. So then when you get it back, you remember like what we did, why we did it. Even you can even write to yourself, remember this or anything like that. All right, good with 2? 4. 28-foot long ladder leaning against a wall makes an angle of 70 with the ground. Determine the vertical height. So a drawing is important every time. 70 degrees with the ground from the ladder, that's here. And if you can make them like graphically accurate, that helps. Like I did that. I didn't actually use a protractor to make it 70, but I have a 45 that's handy, right? So I know it's a lot steeper than a 45. So if you can make this graphically kind of accurate, it gives you an idea of what you're aiming at. Like, okay, H should be less than 28, right? But not a lot less, like 25-ish is my guess. So it's good to kind of, mentally give yourself a little estimate. How are we going to get H? Yeah, not law of sines. Like it though. Sine. Law of sines is that whole sine, A over sine. Sine, cosine, and tangent is the trig functions, right? So sine 48. Why sine? Yeah, it's opposite the angle you know. So here's the angle I know. Here's what I want to know. It's opposite of it. Opposite should trigger sine. Adjacent should trigger cosine. Yeah. So again, you got to have a graphic. You got to put in what you know and where it is. And then think about, oh, is this opposite or is this adjacent? And then go for the function. Sine 48 is opposite H over 28 feet. H equals. How do we get to H? Again, this is just a multiplication. The problem with trig is this is a bit repetitive. Seems like we're always multiplying the 28 times the sine of whatever, right? It's not always the case. So write it out and that's going to say, oh yeah, multiply that across, right? Sometimes you'll be dividing and not multiplying. So it's not always just multiply this times that. But in this case, it is. Why did I put in 48? I don't know. I'm on the last problem still. 70. $28. All right. $26,311. Vertical height. Good. And 5. This one says find C and A with a rise of 6 and a run of 10. You could have drawn it either way, right? You could have drawn the 10 up and the 6 over. I think it just said long side and short side. Find C. 2 legs of a right triangle are 6 and 10. Determine the length of the hypotenuse and the angle opposite the short side. So angle opposite the short side, I put it here and then I labeled it A. So you don't have to label it A, but you got to label it for me. So I know what you're doing, where it is, put it on your graphic so I can see what you're doing. 2 sides. How do we get C? Yeah, Pythagorean theorem, which is what? C squared equals A squared plus B squared. Right triangles only, not non-right triangles. Okay. So that's pretty easy. A squared, since I named that A, I'll use this as A. It doesn't matter what order this is done in, right? Clear the square by taking the square root of both sides. When you take the square root of C squared, it goes to C. And then you take the square root of this side. So again, we had to clear that variable. $11.661. So C equals 11.66 feet. Is that the unit? Yeah. And then with the angle opposite the short side, how are we going to get that? Yeah. So you could use sine, which is opposite over what you just calculated. Just don't round that. What else could we do? Using my rule, which is I don't want to use any numbers I calculate. Yeah, we could use tangent. Sine's not wrong. You can use sine. There's multiple ways to solve these things. But I'm going to use tangent and say 6/10. Because those are the numbers given. Okay, how do we clear the A? Yeah, so it is the inverse tangent, but if I was to algebraically show you, I divide by tan, correct? That's how I get rid of that. Right? So that means I divide this side by tangent, which is the inverse of the tangent, which is typically written tangent minus 1, 6/10. And sometimes you'll see it as a tan, the arc tangent. Oh, no, that doesn't. Yeah, the function works a little different in that this is how you do it. It's going to be the arctangent of 6/10. So I think in a TI, you have inverse tangent. Is that correct? Yeah. So in an HP, the way it's done is you just do the 6 10 divides. So you come up with the number that's inside the bracket. And then I just apply the arctangent to it. So it's going to be shift arctangent. But yeah, either way, should give it to you. As long as you're in degree mode. If you're in radian mode, you'll get a weird number. So 39,637, what I get? I don't know where to write that. A equals 30.96 degrees. Yeah. Excellent. Okay. You can turn those in if you have them, then you don't want to submit them. You want me to check? Yeah. Don't be. So if I give you like a 0 on something, really, I'm just looking for a response from you. But like, I just want to know, okay, these students are looking at their grades now and then. That's a good thing. So, no. All right. Let's kind of wrap up right triangles. Just collect all the rules that we use to apply, and then we'll do non-right triangles. I think you have some homework on that. You have like a dimensional analysis problem too, so we should talk about that. It's pretty simple. But right triangles. So part of the homework format that's actually on Blackboard has an assumptions area. So if you ever assume a triangle to be a right triangle, if you just don't know, but it looks like a right triangle, that's okay. Just write it down. Assume this is a right triangle, okay? But it either should be called out as a right triangle or it should have some kind of notation that it's a right triangle, okay? So we have this formula that we can use. And then we have the, yeah, I need to know that. Pythagorean theorem, right? And then we have these trig functions. So it all sets up from the known angle. That's all of these are going to set up from the known angle. So if you know an angle, if we know angle A, then going after these, that sets up the opposite and the adjacent, right? If you don't know an angle and you just know sides, that's probably going to be tangent to figure out an angle. What else did we have? We had Pythagorean theorem, we had the sine functions. What other strategy did we have? The really easy one. Interior angles. 180 degrees. Okay, that's it. Those are the tools you got. If you have enough information, if you have two things of this triangle, you can solve it out completely. Super important for us because these are going to not be distances in the future. They're going to be vectors. They're going to be forces. So when we have forces going in different directions, we have to figure out what the effect is of that, right? If I have a force going, let's say I have an eye bolt stuck into a wall, right? So this is my wall. This eye bolt is screwed into the wood or it's anchored into the concrete. Somehow it's hard attached, right? And I have 100 newtons pulling in one direction, and then I have 100 150 newtons pulling in another direction. Right? So this is how we're going to apply trig, just big time. So we'll worry about what's going on inside the wall in a bit. Right now, I just want to know what the full effect is on this eye bolt. Right? I got 100 newtons here, 150 here. What's the eye bolt feeling? Is it feeling 250? Probably not. It's definitely feeling 100 pulling out, correct? That's obvious. But it's also feeling a portion of the 150 pulling out and a portion of the 150 pulling up, right? So if I want to know full pull out, like, hey, I know this eye bolt is rated for 500 newtons pull out if it's put in correctly, right? Pull out meaning it's going to just yard it out. So what I need to know is, do I have over 500 pulling out or do I have less than 500? These forces, these add up to the 150. In other words, I can take this little Y force and put it over here and make a what? A right triangle. And now we know how to solve right triangles. Right? I put my little Y force over here. So I added my X to my Y, and the hypotenuse is 150. Right? This is like 2 chapters ahead. We learned trigonometry first, and then we're going to apply it later, but I'd like you to see where we're heading. So the triangle right there, that analysis turns out to be 150. And in order to solve the problem, we would have to have the angle that 150 is acting on. We'd have to have it. Like, you can't just say 150 is there somewhere. Like, what? It's there exactly somewhere. So we'll say that angle is 45 degrees. 150 is acting at 45. So here's my triangle where I have Y, X, and 45 degrees. Everyone see that? See how I got it? Yeah. So this is the force triangle for the 150. It has nothing to do with the 100. 100's acting on its own out here in the X direction. It's an easy force, right? For X and Y. Depends on what our analysis is. If I'm interested in, will the eye bolt bend, right? Will it bend up? Because it's got an upload to it. Then I'd need to know that Y force. Right now, I'm just interested in if it'll pull out, right? I want to know that it's going to stay put. So what do I need? I need this X force, right? And I'm going to take that X force and I'm going to add it to the 100 because they're both working in the X direction. They're both trying to pull this eye bolt out. So how do I get at? How do I get that X? Sine, cosine, or tangent? Why cosine? It's adjacent. Yeah, we want the adjacent and we know the hypotenuse. Right? And this is the angle we know. So it's adjacent over hypotenuse. That is cosine 45 equals adjacent over hypotenuse. What's that number? $106? Yeah, so we'll say it's 107. What the heck? 106.06. And it's all in the X. It's all the pullout. It is the X effect of the 150 because the 150 is off at some angle. So I'm going to take that X and add to that one and get 206. So that's the pullout of that thing. And trigonometry gave it to me once I knew how to put the forces together, right? We'll do like a whole week in this, so don't stress about that yet. But that's why we're doing it. If this was rated at 500, we're good, right? We're actually, magnitude's good. We're at 206. We even have a factor of safety, which is what we want. We want a factor of safety. I'm guessing the 500 rating also has a factor of safety to it. So we're good. All right, that's why we do it. That was a little sidebar, but what the heck. All right, non-rights. What tools do we have for a non-right? They call them oblique, but there's oblique and there's acute. So don't get too wrapped up in the terminology. I'll draw an oblique. So there is an oblique triangle, clearly not a right triangle. Oblique meaning there's one angle greater than 90. Acute would mean all angles are less than 90, but I don't really care about that. Non-right is what we care about, right? If it's a non-right triangle, we do not get any of this. None of this is available, goes away. So if this is the system that we ended up with, and I'll actually just put some vectors on it, and we'll say this is 400 pounds, and we'll say this is 350 pounds. And we'll say we actually know this angle of 120, oops. I want 120. 120 degrees. So, non-rights, you got to know three things. Okay, right triangle, you got to know two things. You're going to struggle if you only know two things of this triangle. So again, draw the graphic, that's important. Put in what you know, that's super important. And then know the strategies for right triangle, non-right triangles. So we know sine law is one of them. So I'm going to write it. A over the sine of A, and the capitals are super important. B over the sine of B, and C over the sine of C. And we can use any two of those. These two, or these two. That's how they work, okay? And what you want to know is, can I set up two of those and only have one unknown? So let's start to label things. I'll call this C, I'll call this C, I'll call this A. It doesn't matter, just got to do it, right? B, so this is little b, and this is A. So label it out, that's going to help a lot. I know these two sides, correct? A and B. Yeah. Do I know angle A? No. Do I know angle B? No, not going to work. So I cannot use those two. I'll end up with two unknowns. All right. Now what? A, I don't know that. I don't know this. Don't know this. I know that, but I don't know that. Can't use this, correct? Not gonna work. Anyone know the other law we have for non-right triangles? Yeah, law of cosines. So this is in the book, like on page, I don't know, 4 or something, early in the chapter. Again, don't have to have these memorized, but we got to know how to run them. So the law of cosines is what? C squared equals A squared plus B squared minus 2AB cosine C. Yeah. That one I happen to know. But again, it's early in the chapter. You can find it. So it works with sides C, A, and B, and angle C. So here's the deal. If you know two sides, it's going to be cosine law. So this is called side angle side. If it's side angle side, it's cosine law. If it's something other than that, you can probably get away with the sine law. And the sine law is a little easier to run mathematically with your calculator, right? This one has lots of opportunity for mistakes. So especially in this area where all this is multiplied together, 2AB cosine C. Anybody check me on that? Did I get that equation right? C squared equals A squared plus B squared minus 2AB cosine C. Got it. So once you figure out this won't work, I would always look for the sine law first because it's easier. But once you figure out that's not going to work, then you got to go to this thing and you just plug and chug. So this is going to set up finding C because I know angle C, that's that. And I know the two sides, that's those. So you just go for it. I'm going to leave C squared as C squared for right now. 350 plus 400 minus 2, 350, 400 cosine 120. Be careful because this gets added to this, and then this whole thing out here needs to be multiplied together. So really be careful with your brackets, with your TIs. Yeah. And don't forget to square the first two numbers. All right, grind that one out. And then in the end, you're going to want to take the square root of that to get C equals. Do we expect it to be bigger than 400? Yeah, if you've drawn it graphically correct, 400's here, 350's here. This should be big, 800-ish. Just estimating it. Anybody get a number? I got 650. How come it's not 800? Yeah, I think my graphic's not very good. Like 120, 120, 90. I think it should be down in here somewhere. And I don't think my 350 is quite long enough. So, you know, if your graphic's not perfect, then Did you square them? 350 squared plus, that should be the steps, right? 350 squared plus 400 squared. Put that into brackets or however you do it. And then subtract this, but the cosine 120 is a negative number. So it ends up adding it. So. Yeah, make sure you can get to 650. Take the time with your calculator to make sure you can get it. Okay, good. So here's the deal with that. So here's my eye bolt again. Now it's buried like this. And we had 400 here. And then we had 350 here. Right? Look the same? Absolutely. So we just made a triangle with it, right? To solve it. So this is the same as if I move this force over here, and then add them together, right? So this 350 comes over here, and we add it together to get the resultant. So again, my angles are slightly off, but that is the way you add vectors together. You put them together tip to tail, even though they're tail to tail right here, because that's how it's applied to the eye bolt, right? But when I pull the vectors out away from the system, I can add them together tip to tail to get what's called the resultant or the single effect, right? So it's interesting that a vector of 400 plus a vector of 350 is 650 because of the angles in which they act on, right? The only time we can just directly add vectors is if we get a load like this, which we will get 400 and, oh, I should make that one 400 and this one 350, right? If the two vectors are directly in line, then we can just add them up. This would be 750, all in the same direction. Yeah. Oh, yeah. Yep. No. We have to use trig to do it. Only time you'd split the difference is if the two forces are equal. 400, 400, 400, 400. Yeah. So if they're exactly equal, then it just splits. Yep. All right, excellent. So we have sine law for non-right. We have cosine law for non-right, both of those. The other strategy is if you can split the non-right triangle into 290s, do it. And then just stay away from these. Because these get complicated and hard to kind of figure out, right? And then what else do we have? We have that. That's true. Interior angles 180. So the addition of that angle, and this angle is going to be 180 degrees. All right. Trigonometry in 2 days. It's worth the time though. Questions? Gonna work one more non-right? Let's do it. I guess I asked him, then didn't even let you answer. I'll make it up. So this hiker walks 400 feet at 45 degrees and then walks 400 feet along the x-axis, and I'd like to know how far from the start they are. A little bit like one of your homeworks you're going to have. So they walk 400 feet, 45 degrees, or what would that be? That would be, this is north, this is west, northwest at 400 feet, right? If it says northwest, that's 45 degrees. And then 400 feet along the X or directly west, how far from their start point are they? So again, what you want to know is that. How far, I'll call it, I don't want to call it X because it's not on the X. I don't want to call it Y. I'll call it D for distance. We kind of reserve X and Y variables for X distances and Y distances. First thing, is it a right triangle? Is it a non-right triangle? Clearly a non-right triangle. Can I just drop a perpendicular and make two right triangles that are helpful? Yeah. Yep. True. Do we have enough information? I don't know if we do. Maybe we do. The 45 is to down here at the x-axis, right? It's not inside this triangle. Keep thinking though. So we do have enough information. They're puzzles, yeah. No, probably not. I mean, it could be, that would be an assumption though. There's something else we can do that's better. Like, what if I dropped a vertical here? And I know 45 here. Right? What's this angle? 45. And since I dropped a vertical, what's this angle? 90. So now I know that angle, 135. Yeah, so there's definitely some puzzling that goes on in these kind of problems. We definitely had enough information. We had 400 feet there and there, like we should be able to figure this out. We just needed another interior angle. We're not going to get this one, this distance, but we could get this interior angle by dropping this, say that's 45, that's 90, add those two, I get 135 for an interior angle. Now I have interior angle, a side and a side. That's sine law or cosine law? Cosine law. Use all those sides. So before you could even decide how to attack it, you had to get more information. You had to dig out an angle. But now we can go after it. The 45 is not part of this triangle. It was just given information in the beginning. It helped us get that, but that's all. All right. So I'm going to actually use d squared instead of c squared because I named it d. 400 squared plus 400 squared minus 2 400 cosine 135. Hmm? It's part of the cosine law. So that's how that law sets up. The cosine law is, yeah, c squared equals a squared plus b squared minus 2ab cosine c. And it's going to be the angle opposite of this. It's that one. Yep. I get 656, oh, 665. Some dyslexia there. Anybody else get that? 565. Jeez. Anybody get that? No? Uh-oh. I might have mucked it up. I'll do it again. I might have mucked that up. $739. Hey, excellent. 0.10 feet from the start distance. Yep. Excellent. So you have a homework problem a little like this, and they use surveying units. So I wanted to make sure to cover the surveying units, which is degrees, minutes, and seconds. So like 40 degrees, 30 minutes, 20 seconds. Have you seen those units before? That's an angle, okay? So the way to get the decimal equivalent, which your calculator needs the decimal equivalent unless you want to switch to survey units in your calculator, which most of us don't want to do. If we have 40 degrees, 30 minutes, 20 seconds, the way to do it in decimal is how many seconds are in a minute? 60. How many minutes in an hour? 60, right? So 60 is kind of the big thing. So this is 20 seconds of a possible 60 seconds. So it's 20/60th. And that will give you the decimal that attaches to the 30 minutes, which is part of 30 is part of 60, right? Because we know that there's 60 minutes in an hour or a degree. So the way to get to the decimal equivalent is going to be 40 degrees. And then this is 30/60th. So that's 0.5. And then this is 20/60th, which is, I'll have to do that one. 0.3. Okay. So the way you get from seconds to the decimal equivalent is the same way you get from minutes to the decimal equivalent. They're just portions of 60. So it's like the 60 scale instead of the 10 scale, but that's kind of weird because we're used to the 10 scale, right? But to get from 40, 30, 20, we take the 20 divided by 60. That gives us the seconds decimal part, and then the 30 into the 60. A little weird, but you're going to need to know that because one of your homework problems gives you this kind of a problem, but then the angle is in surveyor units. Why do they use surveyor units? I don't know. Ask a very old surveyor, maybe they can tell you. We're kind of going away from it because the total station, if you take surveying, gives you degrees in decimal equivalent. So that's kind of nice, but all the old drawings that you come across, like if you go to the county, it's in degrees, minutes, seconds all the time. All right, I have looked over your homework, which is 8, 10, 11, and 37. Chapter 1. 11 is a little bit different. It's not even a right triangle problem. So it's like an algebra problem. So that'll be fun for you. Yeah, it's story problems, which is all we do. Story problems. Life is a story problem, just so you know. You get to figure it out. All right, I think that's enough. Dimensional analysis. I was going to cover that. That is just like, if I have 34 feet, any number that is given to you is given over 1, right? And if I wanted to know inches, how many inches are in 34 feet? Most of us know we just multiply by 12. But if it's a more complicated conversion or dimensional analysis, then you got to be able to write that conversion out and figure out how to get there. Like if I wanted 34 feet in centimeters, that's a different problem. I have to know the conversion though. Like what's the conversion from centimeters to feet? Front cover of the book gives you that stuff. So if you wanted to know feet, you could get to meters. And then maybe if I get to meters, I could get to centimeters because I know there's 100 centimeters in a meter, right? So it says, if you have feet, you multiply by this 0.3048 to get meters. Well, the important thing to know is 1 foot is 0.3048 meters, right? If I put 1 in, I get the conversion. So 0.3048 0.3048 meters per 1 foot. So you can write a conversion either way. I could write the foot on top, or I could write the foot on the bottom. Once you have the conversion, once you go look it up. I put it on the bottom because I want the feet to go away and I want to get meters. That's dimensional analysis, where you use the dimensions to come up with something. Okay, so we'll do this quite a bit. We won't often be converting from like newtons to pounds, but because we're not going to cross a problem. A problem's either US or it's metric. But as we move along, we're going to want to be able to use the dimensions to determine if we're on the right path or not, if we're getting the right answer. Like if I know the answer is supposed to be in meters, then yeah, I'm probably on the right track here. Okay. So then you just multiply the top times the bottom. 34 times 0.3048. Looks like it's 10.36 meters. Dimensional analysis means use your dimensions to help you solve the problem. And if you have to convert, definitely write it out. If I wanted then to get to centimeters, I know there's 100 centimeters per meter, so I would write it that way. So my meters go away, multiply that out, and I'm there. So dimensional analysis just walks you along using your dimensions, crossing out the ones you want to get rid of, keeping the ones that you want. All right, I think we're good.